Okay, so in this video we're going to take the Taylor series at z equals 0 for the log of cosh of z. Now instead of using the standard derivative method, we're going to go for the composition rules. So we basically need to use the Taylor series for some log function and the Taylor series for the cosh function, and then manipulate them together to get the answer to this. So first of all, we see that we're looking for z equals 0. Now, slight problem here because cosh of z is never 0. So what we can say is cosh of z equals 1, and this is all for z equals 0. So what we use in this case is cosh of z minus 1, that is 0. So when we're manipulating this, we can use cosh of z minus 1, but that's going to change the value of the function a little bit. And then that gives us our next problem, which log of 0 is no good. So log 0, that's undefined. So what we can do is, to get to use this minus 1 here, we can go log of 1 plus cosh of z minus 1, then that will equal 0, because the log of 1 will give us 0. So then we need the Taylor series for cosh of z minus 1, so this one, and then the log of 1 plus something, so we use variable w here. So that's the Taylor series is that we need to be able to use this to get the answer to that question. So cosh of z, well, we know what cosh of z is as a Taylor series. This is z squared over 2 factorial plus z to the 4 over 4 factorial plus z to the 6 over 6 factorial, and so on. Now I've missed out the constant here of 1 because this will be a 1 plus, because we want cosh of z minus 1. So what we're looking for, cosh of z minus 1, is this Taylor series. So that's what we're looking for here. Then there's also a Taylor series for log of 1 plus w. So let's write that here, 1 plus w. Now for that, what we have is an alternating series, which is z minus z squared over 2 plus z cubed over 3 minus z to the 4 over 4, and so on. So we just need this part here. Now if you check the links down below, I'll show you how to get these Taylor series. There's some videos there showing you how this is done. Okay, so back to this video. We want now log of 1 plus cosh of z minus 1. So log of 1 plus cosh of z minus 1. So we take this one here, this series here, and what we use is this cosh of z minus 1, wherever there's a z, we plug in this series here. So log of 1 plus cosh of z minus 1, so we have z, so where there's a z we plug in this. So we have z squared over 2 factorial plus z to the 4 over 4 factorial plus z to the 6 over 6 factorial. So that takes care of this term. Now we're on to the second term, minus z squared over 2. So what we can do is take this coefficient out, minus 1/2, and then we're left with the z squared. So we go minus 1/2, and then we want z squared. So now what we do is we plug in this series here and square it. So z squared over 2 factorial plus z to the 4 over 4 factorial. Now I won't plug in the 6 one because when we square it we get up to the z to the power of 12. So that'd just be one step too far really, we don't need that. So let's say up to z to the 6th. Let's make that our last term. So this will give us up to z to the 8, so we won't need that last term when we're calculating, but get us well on our way. So now we want z cubed over 3. So as we did before, let's take 1/3 out, the coefficient. So that's plus 1/3. And now, because it's z cubed, we're now going to cube this series here. Now as we're going to cube it, and we only want up to the z to the 6, this first term is going to give us enough. So z squared over 2 factorial and then cubed. Okay, now do we need this z to the 4? If you put z to the 4 and z squared, that'll give us z to the 8. So that'll be beyond z to the 6. So we don't need to use this term here now. Okay, let's simplify this up. So just having a quick look through here, these are all even powers. So z squared will give us to the 4. 4 squared we don't need, it's up to the 8. We're not going to need that. These are all even powers. Z squared cubed gives us z to the 6. So let's start with all the z squareds. So z squared, what have we got for z squared? We've got basically one term. So that's 1 over 2 factorial. So that's times 1 over 2 factorial. That's the z squared taken care of. Now we need to look for z to the 4s. So let's put plus z to the 4. And now we get together all the coefficients of z to the power of 4. Well, the first one is pretty straightforward. We've got 1 over 4 factorial. Next one, we'll get one in here. So z squared over 2 factorial. And if we're squaring it, so this is basically would look something like this if we're going to FOIL it out. Z squared over 2 factorial plus z to the 4 over 4 factorial. Z squared 2 factorial plus z to the 4 factorial. So basically what we're going to be doing now is FOILing this out. Obviously not forgetting this coefficient here. So for z to the 4, we're going to get a z squared times z squared, and then 1 over 2 factorial times 1 over 2 factorial. So that's then going to give us plus 1 over 2 factorial, and then that's, because that's multiplied together, that's going to be squared. But we've still got this minus 1/2 here. So we multiply that by minus 1 over 2. So that will be all the z to the 4s. That's the 1 in there. There's only 1 in here. When this one's multiplied up, that'll give us, we've got obviously z to the 6 and z to the 8. So that's z to the 4 taken care of. So now we're up to the last term, z to the 6. So what's the coefficients for that? So we've got 1 here, 1 over 6 factorial. That takes care of that. We'll have this one, 2 times 4 and 4 times 2. So there'll be 2 of those. So we'll have, put a bracket here, 2 times 1 over 2 factorial, 1 over 4 factorial. So that's 1 over 2 factorial times 4 factorial. And not forgetting this term here, minus 1 over 2. So we're going to multiply that by minus 1 over 2. Okay, and then there's going to be one more term here. Z to the squared cubed, I'll give us z to the 6. So basically we're going to have a 1 over 2 factorial cubed times 1 over 3. So we'll add that on. So let's just write that down here. Plus 1 over 3. And then times that by 1 over 2 factorial cubed. And then that will end all our z to the 6 terms. So now all we've got to do now is calculate all these in here and simplify it up. So z squared times 1 over 2 factorial. So that's z squared over 2 factorial. That's the z squared's finished. Plus z to the 4. Okay, 1 over 4 factorial. Well, that's 1 over 24. 1 over 2 factorial squared, that's a half squared is a quarter, times minus a half is minus 1 over 8. So that's minus 1 over 8. So that's that one taken care of. And then z to the 6. So let's go careful here. This is looking, could be a little bit tricky. So 2 factorial at the bottom and 2 on the top, they cancel out, they're the same. We've got 1 over 4 factorial, that's 24. And we've got minus 1 over 2, so that's minus 1 over 48. So minus 1 over 48. That's that one there. This one should be a plus. So 1 over 6 factorial, that's 1 over 720. So that's that one. And then the last one, 1 over 2 factorial cubed, that's 1 over 8. And then 1 over 3 times that, that's 1 over 24. But that's going to be a positive. Okay. So now we need to find common multiples for these ones, and then that gives us our answer. So let's z squared over 2. 1 over 24 minus 1 over 8. Well, to get the 24 on the bottom, we're going to have minus 3 over 24. So 1 over 24 minus 3 over 24, that's minus 2 over 24, which is minus 1 over 12. That will give us minus z to the 4 over 12. Okay, that's that one taken care of. So now we're going to have a z to the 6. Okay, common multiple here looks like being 24. So for 24, 24s into 720 go 30. So let's just write this down over here. 30 over 720 for the last one. We've got a 1 for the first one, and then 48 into 720. Well, that's 48 into that go 15. So now we've got minus 15 over 720. So now let's work this out. 30 plus 1 is 31, minus 15, that's 16 over 720. 16s into 720 go 15. Sorry, not 15, it goes 45. So it's 1 over 45. 45 times 16, 720. So that gives us our coefficient here of 45. So z to the 6 over 45. That takes care of that. Okay. So that bit there was just confusing me. We just need to put that bit out of the way there. Okay. So that is going to give us our answer. Z squared over 2 minus z to the 4 over 12 plus z to the 6 over 45. This obviously will keep going on. And then that is the answer to this Taylor series at 0.